students. We are here for another experiment on Introductory Practical Chemistry 2, CHM192. Today's experiment is experiment 6. It's an experiment on carboxylic acid. The title is Experiment on Carboxylic Acid. The aim of today's experiment is the use of equivalent weight in the identification of a carboxylic acid. Carboxylic acids are weak acids with acidity constants in the range of 10 raised to the power -4 to 10 raised to the power -6. Water-soluble carboxylic acids turn blue litmus paper red. Water-insoluble carboxylic acids dissolve in both aqueous sodium hydroxide and sodium bicarbonate. This dissolution in sodium bicarbonate serves to distinguish them from most phenols, which are not soluble in bicarbonate solution. The methods to use in determination of a carboxylic acid is sodium hydrogen carbonate NaH solubility, infrared method, nuclear magnetic resonance method, determination of its equivalent weight, and so on. Examples of carboxylic acids are formic acid, ethanoic acid or acetic acid, propanoic acid, and so on. For your level, the determination of the equivalent weight may be helpful in the identification of a carboxylic acid. For monocarboxylic acids, the equivalent weight is the same as the molecular weight. For a dicarboxylic acid, the equivalent weight is half of the molecular weight. What are the chemicals required for this experiment? You need standard sodium hydroxide solution. You need vinegar or 4% acetic acid by volume. And you need phenolphthalein indicator. The apparatus required for this experiment are your burette, your conical flask, and your beaker. Experimental procedure. Before you start this experiment, it is essential for you to put on your goggles. This is a goggle, a safety spectacle used in the laboratory. You have to put it on to secure your eyes. The next thing you are expected to do is to obtain the molarity of the sodium hydroxide from the label of the bottle and record the molarity on your data sheet. You've been taught how to calculate the molarity of bases in your chapter 1 of CHM191. The next step is for you to clean a burette by rinsing it with tap water and discarding the water. Next, you rinse the burette with 2 5 cm cube portions of sodium hydroxide standard solution, discarding the sodium hydroxide after each rinse. The next step is for you to set up the burette as demonstrated by your lab instructor. You can see the way it is set up here. That's the way you should set up your burette. And fill it with sodium hydroxide standard solution to slightly above the 0 mark. This has been done to make this experiment faster. Then, you drain enough sodium hydroxide solution from the burette so as to remove all air bubbles from the tip of the burette and read the level as shown in figure below. This is the figure you're seeing here. You have to ensure that the solution is at the 0 minus cost. That is what they're trying to say. Next is for you to repeat the steps 2 to 4 for the vinegar burette. This is the vinegar burette. The same thing has been done to the vinegar burette as the sodium hydroxide burette was prepared. We rinsed it and we filled it up with vinegar solution. Now the next thing is you have to drain approximately 5 ml of the vinegar from the burette into a clean 250 centimeter cube conical flask. Drain 5 ml of the vinegar from the burette into your conical flask. To the vinegar sample, add 20 centimeter cube of distilled water, 20 centimeter cube of distilled water, and 4 drops of phenolphthalein indicator. Add 4 drops of phenolphthalein indicator. Please observe the color change of the vinegar solution. After that, carefully place the flask containing the vinegar and the indicator under the burette containing sodium hydroxide. Slowly add the sodium hydroxide from the burette to the flask, while swirling the flask until the solution in the flask is a pink permanent coloration. You're expected to get a faint pink permanent color. Take note of the volume of the sodium hydroxide that's changed the vinegar solution to faint pink color. From what I have here, I have like 39. Record the volume to plus or minus 0.01 centimeter cube on the data sheet for sodium hydroxide. Perform a second titration by refilling the sodium hydroxide burette and repeating steps 6 to 8. Carry out all the necessary calculations. What are the likely questions your lecturer might expect you to have an idea about? Number 1, you may be requested to prepare your titration table. You may be requested to prepare your titration table. You may be requested to calculate the molarity of the sodium hydroxide. You may be requested to calculate the moles of acetic acid. This can be done by using the formula molarity of sodium hydroxide times volume of sodium hydroxide. You can be requested to calculate the grams of acetic acid. So these are what you can be requested to do. Thank you.